One question. Find out volumetric strain and change in volume for the given diagram.
In this question, we have to find out change in volume where the different compressive and tensile forces are acting along x, y and z direction. First step is to find out the stress along x direction, y direction and z direction. So with reference to this diagram, we will take the formula and calculate the stress. So how to find out stress along x direction? So we have to observe this diagram, and this is the direction of x. Now if we observe along the x direction, 300 kilonewton force is acting, and its a direction is inward direction. So this is the compressive force. And if we observe the face along which this force is acting, then here is the length which is equal to 100 millimeter, and here this is the width which is equal to 40 millimeter. So standard unit is meter, and for force standard unit is Newton. So we have to take sigma, that is stress is equal to force divided by area. So what is the area of this face? That is equal to length multiplied by width. So we will take 0.1 multiplied by 0.04, and force is 300 multiplied by 10 raised to 3 Newton. So we will calculate sigma x is equal to 75 into 10 raised to 6 Newton per meter square. Now this type of stress is known as compressive stress because the force is compressive. So we have to use negative sign while we are going to write its a magnitude, and we have to write in the bracket this is the compressive. Now we will calculate stress along y direction. Now if we observe this is the y direction. Now what is the force along y direction? So it is 25 kilonewton, and direction is outward direction. That means this type of force is tensile force. And if we observe the face, then here is the length is given 50 millimeter and this is 40 millimeter. So if we observe the face of this 25 kilonewton force, then these two lengths are inward. So what is the area of this face? That is 0.05 multiplied by 0.04. So we have to take here sigma y is equal to 12.5 into 10 raised to 6 Newton per meter square. And type of stress is tensile stress. So we have to use sign while we are going to write magnitude is positive sign. And we have to take here tensile nature of the stress. Now we will move to calculate the stress along z direction. Now if we observe this is the direction of z. Now the force along z direction, that is the force parallel to this z direction, is 200 kilonewton. So force is equal to 200 into 10 raised to 3 Newton. Now we have to observe the face. So face for which this 200 kilonewton force is acting, whose length is equal to 100 millimeter and this width is equal to 50 millimeter. So we have to take 0.1 and 0.05. So when we calculate, we will get the answer 40 into 10 raised to 6 Newton per meter square. Now the type of force, direction is outward, that is type is tensile force, and we have to give the positive sign while we are going to write its a magnitude of stress, and nature is tensile. Next step is to calculate the strain along x direction, y direction and z direction. When we calculate the strain along x direction, then this is the x direction, and the strain along this direction is known as linear strain, and the strain along other two directions, that is y direction and z direction, is known as lateral strain. Now how to calculate linear strain as well as lateral strain? So formula is linear strain is equal to sigma by E. and lateral strain is equal to minus sigma divided by ME, where the value of M and value of E is mentioned in the question. Now we will calculate the strain along x direction. Now this time we have to take the strain along x direction as a linear direction, and we have to use formula sigma by E, that is sigma x by E. So what is the value of sigma x? It is minus 75 into 10 raised to 6. So we have to take minus 75 into 10 raised to 6 divided by E. Now the strain along y and z direction, we have to take minus sigma divided by ME. So for y direction, minus sigma y divided by ME, that is we have to take minus 12.5 into 10 raised to 6 divided by ME, and strain along z direction minus 40 into 10 raised to 6 divided by ME. Now we will take common term as a 10 raised to 6 divided by E, and remaining term we have to write in the bracket. So if we observe, we can take this minus sign as a common term outside the bracket. So simplified form is minus 10 raised to 6 divided by E, inside the bracket 75 plus 52.5 divided by M. Next step is to calculate the strain along y direction. So along y direction, strain is known as linear strain, and other two directions are known as lateral strain. So rho y is equal to, so we have to take formula along y direction, it is sigma by E. So we have to take sigma y because it is along y direction. So it is 12.5 into 10 raised to 6 divided by E. Now along x and z direction, it is lateral strain. So now we will move to the x direction. So formula is minus sigma divided by ME. But here sigma x is having negative sign. So this negative will become positive. So plus 75 into 10 raised to 6 divided by ME. And then along z direction, it is minus 40 into 10 raised to 6 divided by ME. Now we have to simplify this. We can take 10 raised to 6 by E as a common term, and when we simplify this bracket, then we will get rho y is equal to 10 raised to 6 by E, inside the bracket 12.5 plus 35 by M. Now in the same way we will calculate this strain along z direction. So now this time we have to say that this strain along z direction is known as linear strain, and other two directions are the lateral strain. So how to calculate linear strain, that is sigma by E. So it is along z direction, so we can say that sigma z by E. So it is 14 to 10 raised to 6 by E. Now we will move to the x direction. So x is minus sigma by ME. So here minus minus will become plus. Plus 75 into 10 raised to 6 divided by ME, and remaining direction is y, that is minus 12.5 into 10 raised to 6 divided by ME. So when we calculate this, we will get the answer 10 raised to 6 by E, inside the bracket 40 plus 62.5 by M. We have to calculate change in volume delta V. So formula is volumetric strain is equal to delta V by V. So we have to first calculate volumetric strain. So rho V is equal to rho x plus rho y plus rho z. So we can take each term and we will add all the terms in the form of equation. Now if we observe, here is the minus sign. So we will take this sign and we will multiply with inside the bracket. So we will take from this equation 10 raised to 6 by E as a common term, and inside the bracket minus 75 minus 52.5 by M plus 12.5 plus 35 by M plus 40 plus 62.5 by M. Now we will calculate these three terms. So it is minus 22.5, and then we will calculate these three terms, that is in the form of M. So we will get plus 45.5 by M. Now if we observe, we have given value of M as well as value of E. So when we put M is equal to 4, then we will get inside the bracket we will get minus 11.125. So this negative sign we have to take here, or we have to show here. And when we put value of E, that is 100 giganewton per meter square. So standard unit is Newton per meter square. So we will take this 100 is 10 raised to 2 and this giganewton is equal to 10 raised to 9 Newton. So 10 raised to 9 into 10 raised to 2 in the denominator. So when we again simplify this, then we will get minus 11.125 multiplied by 10 raised to minus 5. So this is known as the volumetric strain. Now we will put this value in this formula and we will calculate delta V. So what is the volume? So volume of this diagram we have to calculate, and that is nothing but here we have to multiply all these three lengths. So we have to take the standard unit as a meter, that is 0.1 multiplied by 0.05 multiplied by 0.04. Now we will calculate change in volume, which is known as decrease in volume, and which is equal to rho V multiplied by V. So we have to take this negative sign and we have to multiply with the volume of this given figure. So it is 0.1 into 0.04 into 0.05. So answer is negative minus 2.22 into 10 raised to minus 8 meter cube. Now this, because of this negative sign, we can say that here is decrease in volume.